In our discussion of sound, we'll start by looking at how sound works in a PC. Three concepts describe how sounds are captured and reproduced. To capture sound waves in an electronic format, sound cards use a process called sampling. This works by taking the state or quality of a sound wave a number of times each second. This rate is measured in thousands of cycles or times per second, or kilohertz. The more often per second a sound is sampled, the better the quality of that reproduced digital sound. PC sampling rates range from 11 kilohertz, which is low quality, to 192 kilohertz, or ultra-high quality. Sounds have a variety of characteristics: loudness or amplitude, range of tone or frequency, and the difference between one instrument or voice and another, or timbre. Each of these must somehow be translated into a digital format. Bit depth is the number of bits per sample that represent these different characteristics. The greater the bit depth, the more characteristics of a sound can be stored and reproduced. The third aspect of sound capture is the number of different tracks of sound. A single track produces monaural sound, and two tracks give us stereo sound. The combination of these aspects determines the quality of a sound. CD quality sound is recorded at 44 kilohertz, 16-bit depth in stereo. Sampled sounds can be saved in several different ways or formats. The oldest format is WAV format. These faithfully store recorded sounds and music, but the files are huge, especially when storing high-quality sound. To make them smaller, algorithms that compress the sound without losing audible quality have been developed. These compressor-decompressor programs, or codecs, make WAV files considerably smaller. The codec you're probably the most familiar with is MPEG-1 Layer 3, otherwise known as MP3. Another format is MIDI. Every sound card has a second processor designed to interpret these files. These aren't like WAV files. MIDI files contain text instructions for the sound card to follow to reproduce a musical sound from instrument samples stored on the card. The card uses one of two technologies to play these sounds, either FM synthesis or wavetable synthesis. To play MIDI files, sound card quality counts. Sound cards with a higher polyphony or more instrument sounds will produce more realistic, better quality musical sound. Obviously, since this is just for musical instruments, MIDI files don't reproduce voice or other sounds. Most files you'll find will be WAV, MP3, or MIDI files, but there are other types out there. AAC is the format for music downloaded into your iTunes library. AIFF is popular on Macs and are often seen on websites. QuickTime Player will play these. ASX was developed by Microsoft for streaming media over the internet through Windows Media Player. ASMWMA are compressed sound formats used on the internet and in streaming sound. RM plays audio or audio and video and is proprietary to Real Media. AU is another popular format which can be played by many different players, including non-Windows systems. FLAC is an open format that compresses sound files without losing data, reducing the size of the files up to 60%. OGG, this Vorbis format, is also open source. These files are saved with a .ogg extension. If you are playing video that has sound, you will also see these formats: AVI, MPEG, MOV, ASF, and RM. Streaming media for playing sound and video over the internet continues to grow. The two most popular players for this are Windows Media Player and iTunes. When you're choosing how to get sound in your system, you have two choices. You can install an expansion card into a slot on your motherboard, either a PCI Express, or USB card, or you can have sound embedded or integrated as a chip on your motherboard as onboard sound. Either way, you'll have the same basic functionality in your system: the ability to capture and to output sound. Sound cards and chips differ in 6 basic areas: sound standards, processor capabilities, speaker support, recording quality, jacks, and extra features. There are 2 sound card standards that most sound cards align with: AC97 or Intel High Definition. The AC97 standard applies to lower-end audio and playback, and recording capabilities are adequate quality for the typical office PC. Intel's high-definition audio was designed to support surround speaker setups and higher quality settings, 192 kHz at 32-bit quality, quite a bit higher than CD quality sound. It can also output to different devices at the same time. The sound processor handles the communication between the application, the operating system, and your system processor, as well as translating commands into sound coming out of speakers or headphones. Low-end sound processors leave the main sound work to your system CPU. Better quality processors take on the sound work themselves, which frees up your processor for other work. Mid and high-end sound processors support various surround sound standards. This provides more realistic sound output, especially in games. Another important part of the sound system is the output device, in most cases speakers. There are several standards to choose from. Stereo is the oldest speaker technology and consists of the familiar right and left speaker connected to a single jack. 2.1 systems consist of a pair of stereo speakers or satellites with a subwoofer. This is a minimum setup for good music outputs from a PC. Surround speaker options. For music, several standards are available here in terms of sound. Dolby Digital supports 5 channels of sound, or 5.1. Digital Theater Systems, DTS, also supports 5.1 surround. DVDs typically support both standards. Higher-end sound cards have a Sony Philips digital interface jack for connecting directly to a 5.1 speaker system or receiver. Games also use 5.1, 6.1, and 7.1 setups, but their standard comes from DirectX. Version 3 of DirectX introduced Direct Sound 3D, which makes sound appear to be coming from many different places. DirectX 8 incorporates EAX, which allowed game developers to manipulate sound to create realistic effects for players. There are a few other things to consider when looking for speakers. Controls that are easy to get at make things easier, and some provide a headphone jack on one of the speakers or on the control box. This means you don't have to wrestle with your case to plug in headphones. Higher-end cards record sound through microphones with less background noise. The quality of signal-to-noise ratio is expressed in decibels. The higher the number here, the better the sound you'll get when recording. High-end cards offer a 96 to over 100 signal-to-noise ratio, which is nearly professional level. The basic jacks on most cards are speaker, microphone, and line in. These are often color-coded. You may also find a line out connector, rear out for rear speakers, or analog digital for external digital devices. Very old sound cards included a 15-pin dB MIDI or joystick port, which is now obsolete. Extra features may include digital output so you can integrate your PC with a home entertainment system and surround speakers, a breakout box which installs into a 5 1/4 inch bay, FireWire connection for direct gaming, file sharing, and MP3 portable device support. A basic microphone is needed to input audio into your PC. If shopping for one, look for something that has good audio quality while still being affordable. In this area, as many others, there's a variety at different price points. MIDI-enabled devices come in several form factors, but most look like a standard music keyboard. They must be combined with the proper software in order to produce music. Today, they connect to systems with USB connectors. Installing an internal sound card is the same as installing any other expansion card in a case. Protect it from static, install it carefully into the proper slot, connect any necessary cables or other connections, and test the system. Windows comes with many built-in drivers for sound cards, but again, check the manufacturer's website for the newest versions. Also be aware that most sound cards come with special configuration programs to fully set up your sound system. Use the Sound applet in Windows to begin the configuration. Here is where you can choose the speaker configuration you're using, as well as volume, and also where you can assign sounds to different Windows events. Make sure you check out all the tabs in the applet to get the best use out of your sound card. Many sound cards also install proprietary software to support any features not provided by Windows. Take the time to check these out and see what additional functions your sound card can perform. Sound problems fall into one of three groups: hardware, configuration, and applications. The first hardware problem often reported is loss of sound. Check power and volume controls on the speaker and then volume controls in your operating system. Sometimes other programs will trigger the Mute All setting in Windows Sound. Go in and uncheck that little box to make your sound return. Another possible problem is that the speakers are failing. Speakers that take a lot of abuse eventually stop giving good sound. Also, poor quality speaker wires can contribute to sound problems. Configuration problems include improper volume settings in the software and driver problems. Check Device Manager and then your Sound applet to look for other configuration mistakes. Application problems usually trigger error messages. It is also possible that sound files are or become corrupted. Try playing the sound in another application or reinstall your application. Sound cards can use a lot of system resources during intense work like gaming. If your system is bogging down at these times, besides checking the obvious resource hogs like video, also check the sound. Built-in sound cannot handle the demands of some games. A sound card with its own processor is needed. There are benchmarking utilities out there that will help you determine if your sound card can handle the tasks that you want to use it with. This concludes our discussion on computer sound.